This is Jiang from China, and it's really very happy to take this opportunity to show and introduce this new topic. Actually, we have already introduced this new work item in WG5, and this time I will very happy to show you the multimodal interaction used in the customer service systems. So we will go through this topic in 5 steps. First, we will try to go through the evolution of the UI interaction for the customer service systems, and then we go through the scenarios and technology used for the multimodal interactions, and then the function view and the architectures, and then we will have a very brief introduce for this new work item. Okay, here it's a very very long period that the network developed, and also according to the development of the network from 2G to the 5G, also the customer systems has already changed, and also the interaction methods changed largely. In the 5G stage, the interaction methods only involve the hard phone. We call to the customer service, use our phone, and through the voice communication. And then there are the IVR, which have already been specified in ISO 8, I think. And then when we go to the 3G, then we can type the short messages through our phone and send to the customer service. And so there's the textual interaction added here. And also we can use our phone to have a phone call and the IVR service there. And then when we go to the 4G, the bandwidth is high, and then we can have some apps we usually use in our mobile phones. So the online video call and voice call from the IM service apps are emerging this time. And there are many access channels like the social app, web chat, WeChat, WhatsApp, something like that. And we also can use the email from the website. And we can have a video call to the others through the VoLTE and send a message, etc. And then at this stage, we already came to the 5G stage. The bandwidth are more higher, and now we go to the high definition video call stage. It's used more commonly now. With AI development, the intelligent chatbot assistant are used nowadays, and we even some CV technology are used in the customer service, like recognize the person to make sure if you are the customer of the enterprise. And also the IVR changed to the IVVR. That means that when we touch a tongue in our phone, they also will play a video with the audio simultaneously at the same time. And in this time, it's the omni channel with the short message and apps and VoLTE and the telephone, something like that. So we just generated the very brief framework for the multimodal interaction of the customer service systems. We can see the left, the external channel. There are many message channels. We can access the customer service through video, through image, through message, through text. They are all go to the applications, then divide to the different functional component to process these messages. The functional components will contain the traditional ARP technology, PTS and ASR here, and also the computer vision. to make face recognition or image analysis. And then the video call, when they can have collaborations in the video call, we share the screen or something like that, and the digital human and the video content sharing, something like that here. So that's the benefits. Before the benefits, we will briefly introduce the characteristic of the multimodal interaction here. Multimodal interaction used in customer service give customers the omni-channel collaboration. It means that whatever you change your channels, you will get the unified routine, the unified queue, and the unified access. And also for the multimodal interaction, we will here include the voice, visual, and the text. So there are many benefits. First is that enhance the satisfaction and the experience for the customer, especially like the high HD, high definition video call I used very friendly for the elderly because they may be confused when they call to a bank and there are too much IVR response navigation very long. But if they have a video call to the agent, it will have a very good experience for themselves. The second is the efficiency and the resolution, enable seamless escalation between channels. And the last is enhance the accuracy and the complementarianess of transmission. Because the different modality will complement each other and help user express their needs and the problem more clearly. Here is the scenarios. First, I will introduce the video interaction used in customer service. The first is the video IVR, the interactive video and the audio response. The first, and the second, the video call, and the third one, the remote diagnosis with customer camera view, and we even can have a video conference like we do in this room, and the desktop sharing and digital agent, and even you can signal your name remotely, and also many special scenarios shown at the last. And here maybe sorry. And not be played. Okay, so just play this one. It doesn't work because the above one is the picture now. This is the digital human from airline, and will give information and the speech response to the customers very friendly. And also this one want to show a scenario about how to issue a credit card remotely. This is the technologies that's used in the first scenario about to remotely issue a credit card. In this scenario, the customer want to issue a credit card, then he makes a call to the bank, and firstly, the agent takes the call and let him move to the high definition video call, and then they can see each other's, and then when he wants to issue the credit card, he needs his identity ID, and need to make the face recognition and to identity to verify his identity. And also, the agent need to share the screens to let him know the rate or something notification about the credit card. So they need to share the screen. And at the last step, he need to sign his name on the screen. That's all the things about collaboration. And they feel very nature, they have a very nature communication with each other. So here in this video interaction for the customer service, there are several relevant technology. First, about the multimodal media transmitting, the video audio encoding, decoding, and the media accessing transmitting through the protocols and the unique router and control technologies. The second is about the CV computer vision technology. You need to recognize the ID, the identity ID, and compare with the database to verify the person. And so here the image analysis and the feature extraction, extraction here are used. Also the screen share and collaboration technology like the file sharing and the annotation, the markup technologies are used, like the HTML or Kevin and something like that. And also the remote signature, here the PDF document processing and format converts, something like that are used in this scenario. And here is the scenario and technology of the speech or text interaction for the customer service. In this figure, we can see there are several types of speech or text interaction for the chatbot. The first is we can input the text and input voice, input video clip, and also can input the position information, the GIS, share your location. So totally in these scenarios, the technology that's used in this text or speech interaction may be mainly already specified in our working group, I think. First of all, they can see in this figure as the procedure of the speech process, speech recognition, SR, and natural language processing, ALP, and also speech synthesis test to TTS. And I already listed the number of the relevant standard here. So all of this will be a good reference for us to working on new work item. So this is a perspective of the business function view of the customer service, and also including the multimodal interaction here. It's a little complex, but we can see there are different layers in the below. This is the infrastructure layer and the support layer of the customer service. This is the media communication layers, which will mainly play a role to process the media access and the short message send, and the core and the routine control, and the audio, video service. And above this layer is the application layers, which can be deployed on our mobile phone or on the website. So that the user can access through the application layers to the customer service systems. So here we go to the function view of the multimodal interaction for customer service. So first is the function view of the speech or text interaction based on the ALP technologies. I think it is really a very traditional technology used for how to recognize the speech, how to change the speech to translate speech to text, and then we use the ALP technology to understand the language and generate the response. This already, I think we already have some standard. Here the 24661. And also another technology about the computer being used for the video interaction in the customer service systems I showed here. I think this is the functional view. Here we have the video audio capturing and the pre-processing module here to capture the video, audio, and images from the user through some device. And then they see the video and the image analysis. We need to make some image classification, object classification, and information extraction, image identification, something like that, and then generate the response there. And also we need to display and transmit the audio video. But here I want to highlight because of the LLM, large language model technologies, is very hot nowadays. And it totally changed the interaction procedure for the users, I think, for the video, audio, and text. In this figure, you can see that the image Peppa Pig, there is the image, and here is the audio, and here is the video. They all go through this large multimodal models. This is the definition here in the right, a large multimodal that conduct end-to-end training across modalities such as text, video, and audio, where all inputs and outputs are processed by the same neural network. So it's really an end-to-end systems that can process all type of input and generate all type of output. So here we don't need to use the traditional process so much steps. First, we need to change the speech to text, and then we need to use ALP and ALU, and then to generate the response and to make a speech synthesis and then give the response. There, in this manner, it's not accurate because some parallel acoustic message are lost in the first step when the speech are changed to the text. And also it needs so much steps, so the response time is long. But as the new technology, it's really very real time and more accurate because the different modality data can complement each others. It can make a LM embedding and element. Then they generate the tokens of all the informations and go through the reading, LM model reading, then gets the response. Here I need to highlight about the LM embedding and element. I make a clear explanation here. The embedding, the model embedding is trying to convert the different type of data, the voice, the video, and the image to vectors. But the vector has many dimensions. So that's the implementation here. So that all the informations here can be embedding and element to data fusion, and get a more comprehensive understanding about the user's need, user's content, and they generate the response. So that's the different for nowadays the interactive technologies. So that we think we need to create a new work item to talk about this new change and architectures about this multimodal interaction for the customer service systems. So we just try to figure out a very brief architecture like this, which need to be deeply discussed in our working group. So this is not the final one. So here there are many layers in the, I think in the below, that's the ICT layer, don't need to be introduced, and so we need to focus about multimodal interaction service layer here. Here we have the speech interaction, the video interaction, and also we have multimodal data processing. This is used by the large multimodal models technologies. So this is the brief introduce about this new topic in WG5. And I think this document provides the characteristics and functional views of the multimodal interaction user interface for customer service systems. And we try to figure out the reference architecture and specify the technical requirement and the recommendations of customer service to implement the multimodal interaction, including the video, audio, image, and so we need you experts, need your comment and your contribute and your anything. Everything is appreciated. Thank you.
Thank you. So I guess the basic message of the last slide is come on board. Any question, comments? Yes. I think you need to get the mic, which got to be somewhere in the room. Thank you.
Do you send us your presentation?
And you need to switch it on.
I have already sent this to Ellen. You want this presentation?
Yes. Presentation materials.
Okay, I think, can we share this to everyone?
Say that again.
Okay, experts want to get this presentation.
Okay, yes, the presentation will be shared, yes, and
Pretty close.
within SC35 and beyond eventually, but yeah. Any question, comment? Yeah. Could you please pass the mic?
Okay, too.
I'm sorry, could you go back to the previous slide with the final architecture? So I'm sorry, I didn't follow that. Where you demonstrate those large multimodal model to this architecture?
I think this part.
So the multimodal data processing?
Yes, I try to merge the traditional way and the new large multimodal models together. So this above layer is related to the traditional way, like the ALP, and this part is referred to the large multimodal models.
Right. Because if we talk about technology, so when we use those multimodal models, it's gonna replace all of those, this layer and up layer. So it's not just about the data processing part.
Yes, maybe. So I thought that this is not the final.
Right.
Yeah, I need your contribution and we can discuss that.
Okay. I have a second question, sorry. So I remember that you compare traditional
Yes.
workflow with those large multimodal models. You said that traditional methods is slow because it's the long.
By now, as my investigation about all the reports from the website that we do have some new technology that's more smart, more real time than this technologies. But that not doesn't mean that all the type of these technology are slow.
Okay, maybe it's my understanding, because, we think the advantage of those LMM you mentioned is that it cannot lose a lot of information, so it can becomes more accurate, but it's slow compared to this one, based on the same resource, or based on the computing resource or something. If we have different conclusion, we can talk about that later, but.
You're welcome. I think it's the accuracy and the response, the time latency of the response really depends on the implementations of the system, related to the computing and the network and all of that. So that's just my opinions for this topic.
Okay, thank you.
Yeah, it's like I said, it's one of the issues with LLMs that they're sort of slow and resource consuming. But I think it's going to improve in the near future with lighter LLMs or so. So this has to be considered. But yeah, that's one of the questions which raised from this presentation.